Thanks for joining us in our Coreform Cubit webinar series. Today, we're going to be talking about our latest release. It's Coreform Cubit 2026.6. Our webinar is going to be led by Dr. Karl Merkley. The capabilities we're going to be talking about today, we've got some new meshing features, some modernization of the user experience, some enhanced interoperability, and as Cubit users know, one of its great strengths has always been the ease with which you can use it with other tools. After this webinar, if you want to learn more about Cubit, you can go to coreform.com/support, and you can find our documentation, training materials, webinars. And this, as I mentioned, is Dr. Karl Merkley. He has over 20 years of experience with Coreform Cubit and is one of the principal Cubit developers to this day at Coreform. So with that, Karl, I'm going to turn it over to you.
One of the new features that has been added that I'm actually kind of excited about is the use of a namespace. Now, namespaces in programming typically are used, like in Python, for example, they're used to separate out different names into totally different categories. In Qubit, the way a namespace works is you push a namespace onto the stack, and then anything that is already named, as it gets modified, the namespace is prepended onto that with a pair of colons. So we can push things onto the stack, pop them off. We can rename namespace items. You can strip a namespace out of a name. You can list them and clear the namespace and start all over. All right, we'll just go ahead and create a simple little brick here. And let's name this as part 1. So it has a name on it. I create a namespace and do a web cut. Now this part is now named left : part. So what happened is the new object that was created as part of this web cut got the new name. So now I can track what actually changed through a web cut. Now, if we do this again, I'm going to go ahead and push another namespace on. I'll push a namespace top on and play that. Now, everything that was in that top one ends up there. If I want to see, well, which one was the top left part, it's that. That's the top, that's on the top, but it was from the original one. So now using these namespaces, I can track what happened through the web cut operation. Qubit has had some ability to create anisotropic elements. This is a more focused ability to say, okay, given like these surfaces, these two curved surfaces, I want to force anisotropy in that area. Anisotropic and isotropic tets are just really long and skinny. And in certain places, you want to add those kinds of elements. In this particular example, they were looking at doing a thermal model, and they just needed to make sure they had lots of elements in a necking area so they could capture that. But the exact shape of the element didn't have to be a perfect tetrahedron for the analysis. We won't do an actual demo of this. Let me share my screen again, but I do want to show and mention one thing. Okay, if I bring back my journal file here, bring up this anisotropic example. This has been true in Qubit for a little while, but I want to reemphasize that we can mix Qubit and Python files in the same journal file. And just point out that with this new release, we are now at Python 3.12. So that's another feature of this release. It doesn't really affect most users, but if you're a heavy Python user, you may want to know that we are now at 3.12. Talk a little bit about Sculpt and some improvements there. I have had some complaints about users, especially when they try to refine a model in Sculpt. Takes lots of memory. Even on big memory machines, sometimes you can run out of memory and it takes a long time. So with this release, we have some improvements with the refinement capabilities in Sculpt. Bottom line is the memory is reduced. For example, in this example, we went down from 6.9 gig of memory down to 4.2, so a 32% reduction in memory. And in speed, it's now 41% faster. So if you're using Sculpt and doing refinement, this is a win. Higher order element metrics. Sandia has been doing a lot with higher order tetrahedra. And as part of that, they've expanded the metrics that are available for both Tri-6 and Tet-10s. What we have are just a number of metrics that now support those nodes, mid-side nodes, mid-edge nodes, actually, in these cases. So there's a list of tetrahedral elements that are supported as Tet-10s. The Jacobians also supported for Tet-10s and 1015s. We won't see much going on here, but because these are all planar. But if I now come into mesh volume quality and pick my quality metrics, I can pick an in radius or a normalized in radius. The normalized in radius does a, where's the in radius? Where's my normalized in radius? Oh, there we go. What it does is it calculates the sphere that would fit inside the tetrahedron. Given 3 points, I can calculate that sphere, calculate that radius, then compare that radius to a sphere of the same volume and its radius. So it's a measure of how much variation there is in volume between an ideal tetrahedron and the tetrahedron that we're given. So in this case, because we're all doing just flat surfaces and regular geometry, the quality is quite good. But that's just an example of that. Next, we have the ability to create cohesive elements. So cohesive elements are used to represent things like glue. So I have two parts that are glued together, and then they're going to be pulled apart as I go through my analysis. But it's not just, I've got something that's still got some mechanical properties that are acting as cohesion as these things split. So currently, note that meshing is required. So before you create this cohesive element, so here I'm creating a cohesive element on this merged surface, and the meshing has to be done first. So we'll share and walk through this example really quickly. Bring back my journal file with my cohesive element journal there. All right, we'll create these volumes. And then we create the block based on surface 5, and surface 5 is that surface that's highlighted in between the two merged volumes. So I create that. Now, if I go ahead and just stretch those volumes, you'll notice that just by moving the top volume up a little bit, I get this gray area in between. So the cohesive elements are represented as a hexahedron or as a wedge if I've got tets. Both are supported. And they're like flat wedges or flat hexes. When I go ahead and start to pull those apart in my analysis, then I can get whatever kind of mechanical properties you assign to those tetrahedral or those flat elements. So if we just undo this back, move it back into place, those are there. So the next part of this is great. I've got these flat elements, but I'm not necessarily using Exodus or using one of Sandia's solvers that supports this. How can I use this in my application? We've added a new command that maps element types for specific solver against solvers element types for other solvers. So in this example, I'm saying I'm creating a solver element that's associated only with block 3 for Abacus, and I'm going to map the Abacus COH3DX type to Exodus 2 hexes. So now, if I go ahead and run that, all right, now if I edit my deck and I look at my Abacus deck, I've got all of the data collapsed here. I can see that on my regular blocks 1 and 2, I'm just using a C3D8R, but on my flat hexes, on my cohesive elements, the block that I specified for block 3 actually comes out with the block type that I specified. So that's a really nice capability in general. It means you don't have to open up your Abacus deck and edit it to get the element type back in there. So there are two versions of this. One is a global version where I create a solver element for a specific solver type. I create a new element that's in that solver type based on the Exodus type. So that means everywhere these will be modified, and otherwise I can specify it on a block specific method. So for example, let's say I have a block that is quad elements, but I'm really doing an axisymmetric model. Okay, everywhere the things are going to be axisymmetric. So I can say, all right, for Abacus, in place of quad elements, I want to use a axisymmetric element for this analysis in Abacus. Now, this is only supported currently for Abacus export. If you have any requirements to do, for example, Nastran rigid bar elements, and you want to substitute those out, let us know. That will be a fairly easy thing to add. So we can expand this as needed, but our initial requests were for some Abacus support. If you need something else, please let us know. Okay, this one's just kind of fun. Visualization of higher order tetrahedrons. From the command line, you can do a graphics shrink 0.3, and that will make your elements shrink in a little bit smaller. Then you have to draw them all. From the GUI, you can come in and say options, mesh default, and change your element shrink. Notice that here, these are integer values. So instead of shrinking them on a factor from 0 to 1, it's from 0 to 100. And actually, it actually showed that, yeah, the value is between 0 to 100, set the shrink factor. Let's just do this from the command line for now. So now you can go in and look at these individual elements, and the shrink factor now, you can actually see on those curved elements that they aren't just straight lines. there is an element there in the middle. And by the way, for those of you who don't know this trick, I'm holding the shift key down. So if I do a shift key and then do a left mouse rotate, it rotates about the location of that. This is not a new feature, but it's a feature that every time I show that to somebody, it's like, oh, I always wanted to do that. So it rotates, picks a location where your currently mouse is at when you do the left click and rotates about it. The other thing that is now the Cubit will do now is if I go into my settings on either Windows or on Linux. So here I'm on Windows 11, and there is if I search for dark mode, it brings up the settings panel. And if I say select dark, Cubit will now work in dark mode. There are still some issues that I find with it. I prefer having my system in light mode, but for people who do want it in dark mode, it is feasible to do this. I think there's some additional work to do on it, and we will continue to work on that. We've expanded import support. There's some additional Abacus support to support mass and connector cards as they come in. For Ideas Universal format, pressure data sets in the Ideas Universal format now create side sets in Cubit correctly. The other one is we have natively integrated the MCNP importer into Cubit such that it is now much more robust. It doesn't go through an extra layer. I did a lot of debugging on this so that all the MCNP examples actually work. All right, change my directories there, reset, import MCNP, and let's do, I think it's boxf.i. Let's see if I remember that. Yep. Okay, MCNP, typically what it does is it will embed the geometry inside what they call a graveyard. MCNP is used for doing radiation transport. So you're essentially firing rays and saying, hey, this is a neutron that's going through and hitting things along a given ray. So if we turn the graveyard off and zoom in, we can see a number of different parts that were created via various constructive solid geometry operations that were then performed in ACES to create these cuts in the different parts. If you get a really, really large MCNP file, it can also take a while to read these in, but you do get progress, you know what's going on. We had a user that was using Gambit neutral files, and they're like, it doesn't work with our process. So Gambit neutral files now support generic side sets as well as CFD boundary conditions. The Gambit neutral file better reflects what's in the documentation as far as line spacing and where things are at. There may still be a few variations from the documented Gambit neutral file, but I never seen the actual Gambit neutral file documentation prior to working on this time. So we just kind of reversed engineered it previously. We now have that access to that documentation. That's been good. If you are Gambit users and you need that Gambit neutral file, it works better now.
I hope you all found that useful. It's always exciting to see progress. And I hope one of the things everyone is taking away from this is that we do listen to customer feedback. We try to prioritize the improvements that make your life better. So if there's something that you'd like to see us try, we can't make guarantees, obviously, but feel free to let us know. We want your life to be easier.
Karl, one thing I've noticed that I was pretty happy about is our documentation for Cubit has had a little bit of a revision. I think it looks prettier. especially in the Python API, which is where I personally live a lot. So that might be something that would be nice to share.
Let's see.
We have a question about the grid program. Walter's asking, is it different from TrueGrid?
I have seen TrueGrid. I have never done a lot of TrueGrid. Greg, have you ever done anything with TrueGrid?
I have not. I know some general things about it. From what I believe I understand, they place a high emphasis on creating like block structured meshes with like high emphasis on orthogonality, which I kind of understand that a little bit from like a fluids perspective. The workhorse in Qubit is the pave and sweep algorithm, and paving just in general, the focus isn't orthogonality. So we don't place quite as high of an emphasis as some other applications might in fully block structured or semi-automated block structured. But I know a lot of people who use TrueGrid and have great success. I think that that's certainly one of the other tools to evaluate if you're evaluating Qubit for sure.
Right. We did have a question, can Qubit do block structured meshing? Yes. The one thing that I did find that I've got to track down is there seems to be a bug with CGNS export in this version. And that traces back to Sandia as well. So need to track, I'm working that with Sandia customers and CGNS export.
Again, thanks everyone for coming. Karl, thanks so much for your preparation and for walking us through the updates in Coreform Cubit 2026.6. Thanks for supporting Greg, and thank all of you for attending. Have a great day.